All right, Introduction to Quadratics. This is section 5.1a. There's another 5.1b, but so starting off with, we're going to talk about the attributes of the quadratic. And so for the quadratic, we have key things to be able to identify. First off, the shape of the quadratic is called a parabola. I almost said parabola. It's called a parabola, okay? And in this case, it opens up. And when it opens up, we call this concave up, okay? This means that its A value, its leading coefficient is positive, okay? And therefore, the vertex is a minimum point. A quadratic can have a maximum of 2 x-intercepts and will only have 1 y-intercept. Got it? This parabola opens down, and we call this concave down. And therefore, its vertex is a maximum point. Easy enough? All right, let's keep it going. So we're gonna start with graphing. So how to graph a quadratic. This quadratic is in the basic standard form. You only have one variable to worry about, and that's your leading coefficient, the A variable. So what we do here is we plot the vertex, 0, 0, draw a dash axis of symmetry at x equals 0, and then we find and plot 2 points on one side of the axis of symmetry. Whether you start on the left or the right is up to you. Then we plot the corresponding points on the other side of the axis of symmetry, and then we sketch the graph. So those are the 4 steps that we're going to follow. Okay, so to begin, we have f of x equals 1/2 x squared. So the first step says to plot our vertex. So there's our vertex at 0, 0. And our axis of symmetry at x equals 0. Okay. Second step says that we're going to choose 2 points, either to the left or either to the right. I just go to the left, mid to the right, because they're positive. Because we're dealing with a fraction, we want to kind of pay attention to the denominator here. So if we look at this denominator, it's a 2. So we want to choose numbers that are multiples, a multiple of 2, so that we don't have to deal with a decimal. Does that make sense? So using our denominator, we want to look for a multiple of 2. Well, my first multiple of 2 would be 2. So I'm going to find f of 2. Now, when I plug in f of 2, I get 1/2 times 2 squared. That gives me 1/2 times 4. And that gives me 2. So at 2, 2, I'm going to go to 2. Still with me? All right, and then what would be my next multiple of 2? 4. So we're going to do f of 4. And so we have 1/2, 4 squared, gives me 1/2 of 16, and half of 16 is 8. So at 4, I would be at 8, which is off the grid. Okay. The next thing we're going to do is we're going to take those points and we're going to reflect them across the axis of symmetry. So how far is this point from the axis of symmetry? 2 units. So if I went 2 units to the right, I'm going to go 2 units to the left. Over here, I'm 4 away. So if I went 4 units to the right, I'm going to go 4 units to the left. And then connect my dots. Well, I'm doing my very best to connect my dots. Boom. And that is how you graph by hand. How do we do? Easy enough? Okay, so here's yours. Give it a shot. All right. So again, practicing with fractions. This time our denominator is a 3. So we want to look for multiples of 3, right? All right. So our vertex is at 0, 0. We have our axis of symmetry at x equals 0. And first multiple of 3 would be 3. So if I plug in f of 3 into this, I end up with negative 1/3 times 3 squared equals negative 1/3 times 9, which equals negative 3. So I'm at 3, negative 3. Bless me. My next would be f of 6. But is that going to fit on here? No, because it's all the way at negative 12. So I have negative 1/3. And that goes off the page, so it didn't help me. I'm just going to use what I have. So I have this point. I'm going to reflect it 3 units over. And boom. Easy enough. Questions about the basic standard form? None? Cool. All right, next. Graphing f of x equals x squared plus k and f of x equals x minus h squared. Okay, so we want to plot the vertex either. So it depends on which one you have. If you're dealing with x minus h, your vertex is going to be at h comma 0. If you have x squared plus k, your vertex is going to be at 0 comma k. Your axis of symmetry also changes. For k, it's going to always be at x equals 0. But if you're dealing with h, it's going to be at x equals h. Other than step 1, everything else stays the same. Cool? All right, let's keep it trucking. So here we have x squared minus 5. So if I have x squared minus 5, I'm dealing with a k value. So that means that my vertex is at 0 comma k. And for this one, my k is at negative 5, right? So I'm going to go to 0, negative 5. And my axis of symmetry is still at x equals 0. Okay. Next, I'm going to choose 2 points to the right. I'm going to do f of 1. Why not? It's a small number. 1 squared minus 5 equals 1 minus 5, which equals negative 4. So at 1, I go to negative 4. I'm going to use 3. F of 3 equals 3 squared minus 5, which equals 9 minus 5, which equals positive 4. So at 3, I'm at positive 4. I'm going to reflect them. 1, 2, 3. 1, 2, 3. One reflection made. I'm going to reflect it. 1, 1. And I'm going to sketch. And there's my quadratic graph. How do you feel? So good? No questions, comments, concerns? No one's like, this is terrible. All right. Now, x minus 4 squared. So the vertex here, it's going to be your h comma 0. Do you guys remember when we talked about absolute value, how we said that our x's are liars? So even though this looks like it's a -4, it's actually a +4. So our vertex is at 4, 0. I'm going to go to 4, 0, and that's my vertex. Which means that my axis of symmetry is at x equals 4. I'm going to choose 2 points. So I'm going to do f of 5. That gives me 5 minus 4 squared, which equals 1 squared. Oh, got a little crazy there. Which equals 1. So we have 5, 1. And then f of 6 equals 6 minus 4 squared, which is 2 squared, which equals 4. So it's 6. I'm here at 4. Cool. I'm going to reflect over. 1, 2, 1, 2, 1. And connect. Uh-oh. Uh-oh. I don't know why that keeps doing that. All right. Do you feel comfortable graphing in those 3 states? Anyone not? Good. Cool. All right. Quadratic forms. So we have 2 types of quadratic forms. We have standard form and we have vertex form, right? So if you think about the examples that we just did, example 1 and 2 are considered standard form, and example 2 and 3 are considered vertex form. But it's just the 2 different ways of writing it. And we're going to go through both, but we're going to focus on both and then kind of mainly focus on vertex form and then transition to standard form. Okay, so how to figure out if the quadratic has a maximum or a minimum. So if you remember from the very beginning, we talked about the a variable, your leading coefficient. So this a. So if you are paying attention to your leading coefficient or your a variable, if it's positive, then you have a minimum. And that because your function is decreasing, then it increases. And that's going to give you your minimum. Hold on. All right, so again, then you have a minimum. So again, if we have a positive a, we have a minimum. All right, if a is negative, then you have a maximum, which means your function is increasing, then decreasing. So we would have a maximum if we have a negative a. Easy enough? So let's make sure you understand. All right, practice 1A. Looking at 1A, is this graph going to have a maximum or a minimum? It's going to have a maximum. Why does it have a maximum? Because the a is negative, right? So this graph is going to be concave down, and therefore it has a maximum point. Okay, practice 1B. What's happening there? Perfect. And that's because Casper the friendly 1, right? If there's no visible a, then we know it's a positive 1. So it's going to be concave up, and it's going to have a minimum point. Cool? Any hesitations with identifying maximum and minimum? Awesome. Next part, y-intercept. So the y-intercept in standard form, the y-intercept is always the c value, okay? In standard form, your y-intercept is always your C value. And that's just the constant, the last number. In vertex form, the y-intercept is the value you get from plugging in 0 for x. So from plugging in 0 for x. So let's look at this one. So practice 2, this is in standard. So in standard form, all you have to do is look at your constant. And what is my constant? 5. So therefore it's 0, 5 is my y-intercept. Easy enough? Okay. Vertex form has a little extra work to do to it. So in vertex form, we actually have to plug in f of 0. So we have -2 times 0 minus 1 squared plus 3. And then we evaluate. So we plug in and evaluate. And that gives us -2 times -1 squared plus 3, which is -2 plus 3. And what's -2 plus 3? 1. So my y-intercept is at 0, 1. So it's a little more, but is it hard? No, not at all. Do you feel confident in your ability to find the y-intercept in vertex or standard form? Yes? Cool. All right. Now, how to find the vertex. So finding the vertex is a little tricky in standard form. When you're finding the vertex in standard form, it's actually a formula for the most part. And so your formula starts here. You have to find the axis of symmetry. And your axis of symmetry is found by doing x equals -b divided by 2a. So we start off with that. Once we find our axis of symmetry, we plug in the value back into our equation and solve for our y. And then what you get from that is your is the y value of your vertex. And then you have your vertex. So start here and then plug in and you're in there. So it's a 3-step process. So let's give it a shot. So we have 2x squared minus 3x plus 5. So to find our x of our vertex, x equals -b divided by 2a. So a, b, c. So we have -3 divided by 2 times 2. And what does that give us? 3/4. So we know x equals 3/4. So that's step 1 done. Step 2 is you take what you got from here and you're going to plug it in. So we're going to find f of 3/4. So we're going to plug this in. So we have 2 times 3/4 squared minus 3 times 3/4 plus 5. And yes, I gave you a fraction because if you can do it with a fraction, you can do it with anything. Does that make sense? So that gives us 2 times 9/16 minus 9/4 plus 5. That gives us 18/16 minus 9/4 plus 5. What has to be true about fractions in order to add and subtract? They have to have the same denominator. And do our terms all have the same denominator? No. So we're going to have to write them with the same denominator. And the easiest way is probably 16. So we have 18/16. Oh, man. That got weird. 18 over 16. How do I turn 4 into a 16? Times 4. And that gives us 30. Oh my gosh. Guys, my pen is not liking me today. And then 5 over 1 would be times 16. And that gives me 980, right? And now can I proceed? 5 times 16? Is that not 80? Did I make that up? Huh? 5 times 16? Yeah. I'm not crazy, am I? No. I mean, I am, maybe. But. All right. So 18 minus 36 is negative 36. Negative 18. Negative 18 plus 80. If you owe me $18 and you have 80, how much will you have left after you pay me? You'll have 62, right? After you pay me, you'll have $62. And this is 31 over 8. So therefore, my vertex is at, look, I was trying to save trees. And that's my vertex. So again, if you can do it with the fractions, you can do it with anything. Got it? Questions, comments, concerns? No? All right. Now, vertex and vertex form is super easy. You just look at your H and your K. Whatever they are, that's your vertex. Just got to remember your X is a liar. So, vertex, what would it be? 2, 3. Vertex, what would it be? There you go. Bam. Hence why it's called vertex form, because it easily tells you your vertex. Cool? All right. We made it.